Hi guys, it's Miss Perry. I want to talk about work and power today. This is section 10.4. Now, work is the transfer of energy that occurs when you apply force over a distance. And the force must be in the same direction that the object is moving. So the force has to be going the same direction. And if you lift a box, then your hands are under it, right? For the most part. And you're lifting it up. So you're applying force to the bottom and it's going up. So you're applying force up and it's going up. If you're carrying a box and walking, you're moving forward, but the box is stationary. Okay, so it's not the same thing. Okay, and our formula is work is force times distance. Force is in newtons, and distance is going to be in meters. And the unit for work is joules. Now, the important thing with work is there has to be motion. There is no work if there's no motion. Remember that. No work if there's no motion. Okay, so let's look at a couple. You're pushing a box horizontally across the table. So is there work going on? Yes. He's pushing it the same direction that it's moving. Okay? You're picking up the box. Okay? You can pretty much tell from the picture that he's pulling up on the box and the box is moving up. So yes, you're holding a box. Now, is that one motion? Is that one work? No, because there's no motion. Okay, so that's one of the important things to remember. If there's no motion, there's no work. Okay, one more. You're holding up a box as you walk. Okay, so is that work? Nope. The force is not in the same direction as the motion. Okay, so let's look at some examples. A box of books has 180 newtons of weight. How much work do you do if you lift the box 0.5 meters? Okay, so that's our formula. And we have 180 newtons. Okay, that's our force. And then 0.5 is your meters in distance. So your answer is going to be 90 joules. Okay, so 90 joules is the amount of work for 180 newtons of weight over 0.5 meters. Now, what if you lift the box a full meter? How much work have you done then? Well, let's go back through it. Now, instead of a distance of 0.5, you have a distance of 1 meter. So that is going to make a difference. And this one is going to be 180 joules. Okay, so if you're doubling the distance or doubling the force, that's going to double the work done. Okay, so in this instance, we double the distance, and that's doubling the work. Okay, now a light bulb is measured in watts. You might look at, I think the new light bulbs don't really have watts on them, I think. But if you look at your parents' power bill, wattage is a measure of the brightness or the power. So power is how fast work is done. If you're working faster, there's more power. Now we know that work is force times distance. Okay, we already know that. We just did that. So power is work over time, or because we know this, power is force times distance over time. Where these are the same thing. Work is the same as force times distance. So you can do either one of these. Okay, so your units are watts. Usually, power is usually measured in kilowatts. And like I said, if you look at your parents' electric bill, then electricity is sold by kilowatt hour. And that's 1 kilowatt for 1 hour of time. Okay, so let's look at some examples. An electric motor lifts an elevator 9 meters in 15 seconds. If the weight of the elevator is 12,000 newtons, how much power does the motor exert? Okay, so let's look and see what we have. We have 9 meters, that's our distance. 15 seconds, that's our time. And the weight of the elevator is 12,000 newtons. That's your force. Okay, newtons is force. So how much power does it exert? We're going to plug everything in. And you get 7,200 watts. Okay, how much power would it exert if it took 30 seconds? Well, let's go back and see. Remember, it was 15, now it's 30. It's going to be 3,600 watts. Okay, so let's practice. This is the application problems on page 240. So let's take a look at these. A warehouse worker moves a box of equipment weighing 250 newtons onto the top of a shelf that is 1.5 meters high. How much work did he do? Okay, so we know force is 250 newtons because it told us that's the weight. Remember, weight is not in pounds, weight is in newtons. Weight has to do with gravity. Okay, so again, your force is 250 newtons. Your distance is 1.5 meters. So we're going to plug it in. And your force, 250, distance is 1.5, and you're going to get 375 joules. Remember, work is in joules. Okay, so calculate how much work is done to push a stack of books across a 1.5 meter table with a force of 12 newtons. Okay, so let's look at what we have. We have force and distance, and we want to know how much work. Okay, so you have work is force times distance. Then you're going to plug that in and get 18 joules. Okay? Now, if it took a gardener 20 minutes, or since we're doing meters per second and we're doing a lot of, seconds is our normal unit that we use for time. So if a gardener took 1,200 seconds to finish tilling his garden using 3,500 watts of power, how much work did he do? Okay, so I gave you the little triangle down here because you're looking for work and not power. Okay, so power is work over time. But according to our triangle, work is power times time. Okay, so you have 1,200 seconds, 3,500 watts of power. Okay, so that's telling you what I just said, that power is work over time, and work is power times time. Okay, so work is power times time, 1,200 times 3,500. So work is 4,200,000 joules. Okay, don't be afraid of big numbers. Okay, so it takes a boy 1 hour to mow the front lawn on Saturday morning. The following week, he does the same lawn in 0.5 hours. Since he's mowing the same distance, the work is the same. Did the boy use the same amount of power the second time? Okay, so let's think about this for a minute. He's going the same distance, so distance is the same, but your time is different. Okay? So he does the same job for half the time that he did the first time. Okay? So is he using the same amount of power? Because everything else is the same. No, he used twice as much power. Okay, so think about it. He mowed it twice as fast. Okay, that's kind of what that means. Okay, so your assignment is to complete the work and power practice, and that's going to be on RenWeb. So take a look at that. Message me if you have questions. Talk to you later, guys. Bye.